Hello everyone, welcome to Philos Academy. In this video, we are going to take some questions on discrete random variable and also see how to solve them. So without wasting much time, let's start. Question 1 says, use the probability distribution given to answer the questions below. So we've been given a probability distribution to answer question A to C. So A says, calculate the mean, variance and standard deviation. So to do that, the mean, mu, or you can write it expected value of x, is equal to sum of xi pi. What it means is, you should take the first x and multiply it by its probability plus the second x multiplied by its probability plus the third x multiplied by its probability up to the last one. That is the meaning of this formula. So let's do that. Now when we take the first x, which is 0, we multiply it by its probability, which is 0.20, plus, then we take the second one, 1 times 0.25, plus 2 times 0.15, plus 3 times 0.10, plus 4 times 0.20, plus the last one, which is 5 times its probability, which is 0.10. So 0 times 0.20 give us 0, plus 1 times 0.25 should give us 0.25, plus 2 times 0.15 should give us 0.30, plus 3 times 0.1 should give us 0.30 also, then plus 4 times 0.20 should give us 0.80, plus 5 times 0.10 should give us 0.50. So when we add them together, 0 plus 0.25 plus 0.3 plus 0.3 plus 0.8 plus 0.5, you get 2.15. So the mean is 2.15. So let's go to the second one, which is the variance. Now to find the variance, the formula is sum of xi square times pi minus mean square. Now what this means is, we should square each x value and multiply it by their various probabilities. So let's do that. When we take the first x value, which is 0, we square it and multiply it by its probability, which is 0.20. We are finding this separately before we subtract the mean from it. Plus, the second x is 1. Let me put this in a smaller bracket. So let me open a big bracket here. Now, the second x is 1, right? So we say 1 square times its probability, which is 0.25, plus the next s is 2, so we say 2 square times its probability, which is 0.15, plus the next x is 3, so 3 square times its probability, which is 0.10, plus the next s is 4, so we say 4 square times its probability, which is 0.20, plus the next s is 5, so 5 square times its probability, which is 0.10. So we close the bracket, minus the mean square. Now we got the mean to be 2.15 here, isn't it? So we substitute 2.15 here square. So this will give us into bracket 0 square is 0 times 0.20 give us 0 plus 1 square is 1 times 0.25 will give us 0.25 plus 2 square is 4. So 4 times 0.15 should give us 0.6 plus 3 square is 9 and 9 times 0.1 should give us 0.9 plus 4 square is 16 and 16 times 0.2 should give us 3.2 plus 5 square is 25. 25 times 0.1 should give us 2.5 minus, now 2.15 square will give you 4.6225. So when we add all this together, you will get 7.45 minus 4.6225. So 7.45 minus 4.6225 will give us 2.8275. So the variance is 2.8275. Now for the third one, the standard deviation. To get a standard deviation is always equal to the square root of variance. So if we know the variance to be 2.8275, then the standard deviation will be square root of 2.8275. And square root of 2.8275 will give us 1.6815. So that is the answer to question A. Now question B says, what is the probability of getting a 2 or a 4? Now, probability of getting a 2 or a 4, probability of a 2 or a 4 should be equal to probability of getting 2 plus probability of getting a 4. So, what is the probability of getting a 2? It is 0.15. So we put it there, 0.15 plus. What is the probability of getting a 4? It is 0.2 or 0.20. So when we add them together, 0.15 plus 0.20 give us 0.35. So the probability of getting a 2 or a 4 is 0.35. Question C says, what is the probability of not getting a 1? Now, to solve this, let me erase this part so that I can write here. Now, probability of not getting a 1, not 1, should be equal to 1 minus probability of getting a 1. Probability of not getting a 1 should be equal to 1 minus probability of getting a 1. So that will give us 1 minus, what is the probability of getting a 1? It is 0.25. And this will give us 1 minus 0.25 is 0.75. So the answer is 0.75. Another way of doing this question C is, the question says, what is the probability of not getting a 1? So not getting a 1 means you are not getting this. So it will be probability of getting a 0 or 2 or 3 or 4 or 5, but not 1. So you add probability of 0 to that of 2 to 3 to 4 to 5. When you add them together, you definitely get this 0.75. So let's proceed to the next question. Question 2 says, use the probability distribution given to answer the questions below. So we have this probability distribution. So question A says, find the value of y. Now, to find the value of y, it is important to know that the sum of all the probabilities should be equal to what? 1. So if that is the case, it means we should add these various probabilities and equate it to 1. So we will have 0.15 plus 0.35 plus y plus 0.10 plus 0.05 plus 0.20. Then we equate it to 1. So let's add these ones together. So 0.15 plus 0.35 gives us 0.5 plus 0.1, that is 0.6, plus 0.05, that's 0.65, then plus 0.2, that's 0.85. So we have 0.85 plus y equals 1. Now we want to find the value of y, isn't it? And we have a plus here. So what we do is to group like terms. So grouping like terms, we have y equals 1 minus, when this positive 0.85 comes to the side, it becomes minus, so minus 0.85. So y is equal to 1 minus 0.85 is 0.15. So the answer for y is 0.15. So the value of y is 0.15. So let's solve question B. Question B says, find the probability that x is less than or equal to 2. B. Probability that x is less than or equal to 2 means that x is exactly 0 or x is exactly 1 or means plus. Probability that x will be exactly 2. The reason I include this 2 is that it says less than or equal to, so 2 should be part. If it says less than 2 without the equal to sign, you won't include 2 in it. But it says less than or equal to 2, so 0 or 1 or 2. So this will give us, what's the probability that we'll get a 0? It is 0.15 from the table. Then plus 1 is 0.35 plus 2 is 0.15. So 0.15 plus 0.35 is 0.5 plus 0.15, that is 0.65. So the probability that x will be less than or equal to 2 is 0.65. So let's solve question C. Question C says we should find the probability that x will be greater than 3. Now the probability that x will be greater than 3 should be equal to the probability that x is exactly 4 or x is exactly 5. The maximum is 5, so we stop at 5. Greater than 3 means 4, 5. So what is the probability that x is exactly 4? It's 0.05 plus the probability that x will be exactly 5 is 0.20. So 0.05 plus 0.20 will give us 0.25. So the probability that x will be greater than 3 will be 0.25. So let's proceed to the next question. Question 3 says, use the probability distribution given to answer the questions below. So we have this probability distribution, and A says, verify that the function is a probability mass function. So A, to verify that a function is a probability mass function, it means that the sum of the probabilities must be equal to 1. So the sum of the probabilities up to the last term, from the first to the last, must be equal to 1. It is a must that it should be 1. So let's verify if this is equal to 1. If it is, then It is a probability mass function. So to do that, we say 0.05 plus 0.20 plus 0.25 plus 0.20 plus 0.10 plus 0.15 plus 0.05. Let's add them. 0.05 plus 0.2 is 0.25. Please use your calculator. Plus 0.25 will give us 0.5. Plus 0.2 will give us 0.7. Plus 0.1 will give us 0.8. Plus 0.15 will give us 0.95. Then plus 0.05 will give us 1. So it is a probability mass function. Now let's go to question B. Question B says, find the probability that there will be 3 or more calls. Now, the probability that there will be 3 or more calls, means you should find the probability that x will be greater than or equal to 3. 3 or more. So greater than or equal to 3. So which means probability that x is exactly 3, or probability that x will be exactly 4, or probability that x will be exactly 5, or probability that x will be exactly 6. So this will give us, what's the probability that x will be exactly 3? Is 0.20. Plus x will be exactly 4 will be 0.10 from the table here. Then x will be exactly 5 will be 0.15. Plus x will be exactly 6 will be 0.05. So 0.2 plus 0.1 is 0.3. Plus 0.15 is 0.45. Plus 0.05 is 0.5. So the answer is 0.5 or 0.50. Now, another way of getting this is, since you are finding 3 or more, you can find the probability that they will be less than 3 and subtract it from 1. So the probability that they will be less than 3 will be 0.25 plus 0.2 plus 0.05, which will give you 0.5. So you subtract it from 1. 1 minus 0.5 will give you the same 0.5 here. So that's another method of getting your answer. So let's look at question C. Question C says, find the probability that there will be at most 3 calls. At most 3 calls. So probability that there will be at most 3 calls means probability that x is less than or equal to 3. At most 3 means that maximum should be 3. It means from 0 to 3. Or from anywhere it starts from to 3. Maximum should be 3. That's the meaning. At most 3. Okay. So that will give us probability that x is exactly 0, or x is exactly 1, or x will be exactly 2, or probability that x will be exactly what? 3. So probability that x will be exactly 0 is 0.05. Plus probability that x will be exactly 1 should be 0.20. Plus probability that x will be exactly 2 will be 0.25. Plus probability that x will be exactly 3 will be 0.20. So let's add them together. 0.05 plus 0.20 plus 0.25 will give us 0.5 plus 0.20, that's 0.70. So the answer is 0.70 or 0.7. Okay, so let's go to the next question. Question 4 says, the discrete random variable x has the given probability distribution. So this is the probability distribution. So find A, the value of z. So for A, now to find the value of z, we should know that the sum of the various probabilities from the first to the last should be equal to 1. So if that is the case, then z plus 0.2 plus 0.4 plus 0.25 plus 0.1 should be equal to 1. So we will have z 0.2 plus 0.4 is 0.6, plus 0.25 will be 0.85, plus 0.1 will be 0.95. So we have plus 0.95 equals 1. So if we make z the subject, we will have 1 minus 0.95, which will give us 0.05. So the value of z is 0.05. Now question B says, we should find the probability that x is between 4 and 7 inclusive. Because of the equal to sign here, it means that 7 is included and 4 is also included. So to solve B, probability that x is between 4 and 7 inclusive should be equal to probability that x is exactly 4 plus probability that x is exactly 5 plus probability that x is exactly 6 plus probability that x is exactly 7. If it says less than without the equal to, then 4 and 7 will not be included. But if there is equal to here and there is no equal to here, you won't include 7 but you will include 4. If there is equal to here and there is not equal to here, you will include 7 but you won't include 4. But you have the equal to in the both, so you should include 4 and 7. That's the meaning. So let's solve that. Probability of getting a 4 will be what? 0.2. And probability of getting a 5 will be 0.4. Plus probability of getting a 6 will be 0.25. And then the probability of getting a 7 will be 0.1. So let's add them. 0.2 plus 0.4 is 0.6. Plus 0.25 is 0.85. Then plus 0.1 is 0.95. So the answer to this is 0.95. Now let's proceed to question C. Question C says, we should find the probability that x will be greater than 5. So to get the probability that x will be greater than 5, it should be the probability that x is exactly 6 or x is exactly 7, because these are the values greater than 5. 6 and 7 are greater than 5. So what is the probability of exactly 6? It's 0.25. Plus, what is the probability of exactly 7? Is 0.1. So 0.25 plus 0.1 will give us 0.35. So the answer for question C is 0.35. So let's proceed to question D. Question D says, we should find the probability that x is between 3 and 7. It means that probability that x is exactly 4 or x is exactly 5 or x is exactly 6. We won't include 7 and 3 because there is no equal to here or here. So it's between 3 and 7. So the values between 3 and 7 are 4, 5, and 6. So we add their probabilities. So what is the probability of getting exactly 4? Is 0.2. Plus exactly 5 is 0.4. Plus exactly 6 is 0.25. So 0.2 plus 0.4 is 0.6. Plus 0.25, we have 0.85. So the answer for question D is 0.85. Now let's proceed to the next question. Question 5 says, the random variable x has the given probability distribution as shown in the table. So we have this table. Find A, mu, that is expected value of x. So to find expected value of x, which is mean, the formula is sum of xi times pi. It means that x1 times p1 plus x2 times p2 plus x3 times p3 plus x4 times p4 plus x5 times p5. That's the meaning. So to do that, we will have our x1 is what? Is 1 times p1, which is 0.07, plus our x2 is 2 times its probability, 0.15, plus the third x, which is 3, times its probability, which is 0.45, plus the next x, which is 4, times its probability, which is 0.20, plus the next x is 5, times its probability, which is 0.13. So 1 times 0.07 will give us 0.07, plus 2 times 0.15 is 0.3, plus 3 times 0.45 is 1.35, plus 4 times 0.2 is 0.8, plus 5 times 0.13 is 0.65. So let's add them together. 0.07 plus 0.3 plus 1.35 plus 0.8 plus 0.65. Kindly check it for me. I think you get 3.17. So let's look at question B. Question B says we should find expected value of x squared. So expected value of x squared should be equal to sum of xi squared times pi. What it means is you take the first x and square it and multiply it by its probability plus second x squared times its probability plus the third x squared times its probability continuous to the last x. So let's do that. The first x is 1. So we say 1 squared times 0.07, which is its probability, plus the second x is 2. So we say 2 squared times 0.15, plus 3 squared times 0.45, plus the next s is 4. So 4 squared times its probability is 0.20, plus the next s is 5. So we say 5 squared times its probability, which is 0.13. So 1 square is 1 times 0.07, we get 0.07, plus 2 square is 4, and 4 times 0.15 should give you 0.6, plus 3 square is 9, and 9 times 0.45 should give you 4.05, plus 4 square is 16, and 16 times 0.20 should give you 3.2 or 3.20, plus 5 square is 25, and 25 times 0.13 should give you 3.25. So when we add 0.07 plus 0.6 plus 4.05 plus 3.20 plus 3.25, we'll get 11.17. So the expected value of x squared is 11.17. So let's proceed to question C. Question C says we should find the variance of x. Now to get the variance, the formula is expected value of x squared minus mu squared, or you can write it expected value of x squared minus expected value of x squared. Expected value of x is the same as mu, so you can choose to write it like this or like this. But from B, we've gotten expected value of x squared to be 11.17. Then minus, now from A also we've gotten expected value of x to be 3.17. So we substituted the 3.17, but we square it. So that will give us 11.17 minus 3.17 square will give you 10.0489. So 11.17 minus 10.0489 will give you 1.1211. So the variance is 1.1211. Now to solve D, which is the standard deviation, you must know that standard deviation is the square root of variance. So if that is the case, then we got variance to be 1.1211. So it will be square root of 1.1211. So square root of 1.1211 will give us 1.0588. So the standard deviation is 1.0588. So let's proceed to the next question. Question 6 says, M and M sweets are of varying colors, and the different colors occur in different proportions. The table below gives the probability of the varying M and M sweet colors. So we have this. These are the various colors and their various probabilities. So question A says, what is the value of C? To get the value of C, we should know that sum of the various probabilities is equal to 1. So if that is the case, then 0.3 plus 0.2 plus 0.2 plus 0.1 plus 0.1 plus C should give us 1. That's the meaning. So 0.3 plus 0.2 is 0.5, plus 0.2 is 0.7, plus 0.1 is 0.8, then plus this 0.1 is 0.9. So we have 0.9 plus C is equal to 1. So if we make C the subject, we have C is equal to 1. When this comes here, it becomes minus 0.9. So C is equal to 1 minus 0.9, which is 0.1. So our C is 0.1. Question B says, you draw an M&M at random from a pocket. What is the probability of each of the following events? I. You get a brown one or a red one. Now, to solve question B, I. Probability of getting a brown one or a red one should be equal to probability of getting a brown plus probability of getting a red. So what is the probability of getting a brown one from the table? Probability of brown is 0.3. Then we add it to probability of red, which is 0.2. So 0.3 plus 0.2 will give us 0.5. So let's go to Roman number 2. Roman number 2 says, what is the probability that you do not get a yellow one? Now, there are two ways of solving this. Now, the probability that you do not get a yellow, do not, okay, that's why I added. Look at the sign at the top here. Probability that you do not get a yellow should be equal to 1 minus probability of getting a yellow. So, we have 1 minus, what is the probability of getting a yellow? Probability of getting a yellow is 0.2. So 1 minus 0.2 will give us 0.8. Now, the second method goes like, probability of not getting a yellow should be equal to probability of getting either of the others. And when I say either of the others, it means that probability of getting a brown, or let me say plus, probability of getting a red or a green or an orange or a tin. but not yellow. Okay, so what is the probability of getting a brown? 0.3 plus red 0.2 plus green 0.1, which is 0.6, plus yellow 0.1, which is 0.7, then plus 10, which is 0.1, that gives you 0.8. So you see that we get the same answer, 0.8. So let's proceed to Roman number 3. Roman number 3 says, you don't get either an orange or a thin one. The probability of not getting either an orange, not orange, or thin, it's neither of them, should be equal to 1 minus probability of either of them. It should be 1 minus probability of getting an orange or a thin. Okay, don't. So it should be 1 minus probability of getting an orange or a thin. So that will give us 1 minus into bracket probability of getting an orange plus probability of getting a thin one, which will give us 1 minus into bracket, what's the probability of getting an orange? Is 0.1 plus probability of getting a thin is also 0.1. So that will give us 1 minus 0.1 plus 0.1 is 0.2. So 1 minus 0.2 is 0.8. So the answer is 0.8. Another way of getting it is probability of not getting an orange or a thin should be equal to probability of getting a brown, or means addition, probability of getting a red or a yellow or a green, but not orange or thin. So what is the probability of getting a brown? 0.3 plus a red is 0.2 plus a yellow is 0.2 plus a green is 0.1. So 0.3 plus 0.2 is 0.5 plus 0.2 is 0.7 plus 0.1 is 0.8. So you see that we get same answer for this and this. So let's look at Roman number 4, which is the last one. I'll write it here. So Roman number 4. What is the probability that you get one that is brown or red or yellow or green or orange or thin? It looks like all the colors have been mentioned. We have brown, red, yellow, green, orange, thin. So there's no need solving this. The answer is 1. But to clear doubt, probability of getting a brown or red or yellow or green or orange or thin should be equal to probability of brown plus probability of red plus probability of yellow plus probability of green plus probability of orange plus probability of the thin one. So brown is 0.3, red is 0.2, yellow is 0.2, green is 0.1, orange is 0.1, and 10 is C, and we've gotten C to be 0.1. So when we add them together, you definitely get a 1. So that's the answer to this 1. So I'll end it here for now. Please, if you are new to this channel, please do well to subscribe so that whenever I post important videos like this, you always have access to it easily. Thank you for watching.